All right, so welcome back to everyone. A very warm welcome to all of you guys. So, hello Shivsai, hello Bima. So, all the live students, welcome to the session. Okay, so I hope you guys can see me and hear me properly. So, I am your very own physics educator, Dr. Umashankar Tripathi. Okay, so Shivsai, I just checked that question. So, in that, there was something we missed. So it was 6t square plus 4tj. This was the question. So now I think we can solve it. Are you getting my point? Okay. Okay. So 6t square plus 4tj. Shishay, are you there with that? So this was the question basically. So it was given 0 to 3 seconds. So see, acceleration is not constant. So we cannot uh, okay, so this was the question actually. I just seen the data. So see, sometimes when the question is having the error, so that is why I'll be more careful next time. Okay, it was my mistake that I haven't cross-checked the question. So now you can do it. So if we divide it by mass, it will become 2t square I plus 4t of j. Now if we integrate this, this will become 2t cube by 3I plus 4 by 3 it was. So 4 by 3 t square by 2j. Okay, now you put the value of t, that is 3. So it will become 18I plus 6 of j. Yeah. No, I think everybody will be able to solve now. Okay, so I'll be more careful. Okay, anyway. So now let's start with today's session. Okay, so guys, in the last session, I was speaking about the dot product of vector. Okay, the dot product of vector, and we have learned that. So I hope the last session was clear, right? Okay, the last session was in the last session we have seen that if two vectors, if you want to do the dot product of two vector, it is a b cos theta, and I have given you the interpretation of it, that how this becomes a b cos theta. So basically when you are taking a dot b, okay, a vector dot b vector, then we are writing a b cos theta. So b cos theta is nothing but the component of vector b in the direction of a. So this is something we've seen in the last session. So if this is a vector, this is b vector, the angle is theta. So the dot product is ab cos theta, right? Okay, so we have learned about it. Now let's continue from that point. So today we will try to complete as much as possible. Okay, so that we can see more questions. So now coming to the properties of dot product. Okay, what are the properties of dot product of two vectors? Yeah, she's right. Please ask me that. What is your doubt? Please ask me the doubt, beta. You're saying what is the differentiation of d sine 30 dx? Am I you are asking this? What is d by dx of sine 30? This is what you are asking for. D by dx of sine 30. First tell me, are you asking this? Am I getting you right or wrong? This is what you are asking, na? D by dx of sine 30. Right? Now, if you are asking this, just tell me one thing. Sine 30 is a constant or not? What is the value of sine 30? What is the value of sine 30, beta? Is it a constant or not? It is a constant. Now tell me, if some constant is differentiated, what is going to be the answer? If some constant is differentiated, what is going to be the answer? Yeah, sine 30 is 1 by 2, so this is a constant. Now, if any constant is differentiated, what is going to be the answer? Can you tell me that? Hmm? So this is 0 also. What is the doubt in this? See, whenever you are differentiating any constant, it is 0. Whether you are differentiating sine 30, cos 30, sine 90, anything, that is going to be 0. Okay? It is not going to become cos 30. Understood, beta? Okay? Yeah. So it is obviously, see, any see, there is no scope of doubt in this. Okay? You are a very intelligent student. Any constant when differentiated, it will become 0. Differentiation means change, isn't it? It's slope. Okay, slope of something. Y2 minus y1 upon x2 minus x1. So when constant is differentiated, there is nothing going to be changed in that. Okay, clear? Shall we move ahead now? Okay, wonderful. So now let's say what is the properties of dot product. See, very very important discussion. So see, the first property of the dot product that it obeys commutative law. It obeys commutative law. Now, what does that mean? So, dot product is commutative. That means if you write A dot B vector, it is also equal to B dot A vector. B dot A vector. Right? Okay, sir, how come, sir? Obviously, if you write A dot B, A dot B. Okay, this is AB cos theta. And when I write AB, I refer to the magnitude, When you write B dot A, it will be BA cos theta, isn't it? BA cos theta. So see, these A, B cos theta, these are constants. So three constants are multiplied with each other. No matter in what order they are going to get multiplied, you are going to get the same answer. So the dot product is commutative. Okay. Now second thing is second law. It obeys distributive law. It obeys distributive law. Okay. Now, what do we mean by? Oh, wonderful. So you got 650 out of 750. That is a very good mark. Wonderful. How many students have appeared in this examination? Wonderful. See, giving these kind of a test is very important. So you almost give the dot product, the test like that. So it is going to help you. Wonderful, beta, wonderful. Keep giving these kind of tests. Okay. Okay. So this will give you an insight that where you stand in the competition as well. So now it obeys distributive law. So what is distributive law? So you can write A dot B vector plus A cross C vector. Understood, beta? A dot B plus A cross A dot C. Okay. Okay. Now similarly, if we write so simple like how we do algebraic multiplication, we can do it like that also. Okay. So let's suppose A vector plus B vector into C vector plus D vector. So how you can write it? So you can write it A vector dot C vector plus A vector dot D vector, like simple algebraic multiplication, how we do, plus B vector dot C vector, okay, plus B vector dot D vector. Okay, so basically it obeys distributive law. Now, very important is, okay, dot product, the third property is dot product of a vector, dot product of a vector with itself, dot product of a vector with itself gives a square of magnitude. With itself gives a square of magnitude. Okay, this is a very very important property, and this is going to be of high use lately as we are going to see it. So now please understand this how what is the meaning of it. So dot product of a vector with itself gives a square of a magnitude. So if there is a vector A and if I do the dot product of it with itself, that means A dot A. So it is going to be A. So if we do like what we do, so this is A cos theta, isn't it? The magnitude of A, then the magnitude of A, then cos theta. Now two vectors multiplied. So a vector multiplied by itself. So if you assume that these are two vectors, so what is going to happen, Mira? What is going to happen? So what is the angle between these two? So obviously this is 0. What is the angle a vector made with itself? So it is 0. So cos theta, cos 0 is 1. So this will become a square. Okay, this will become a square. Now similarly, if I ask you like sir I cap dot I cap, I cap dot I cap. So this will become I square. Okay, that is it will become 1, isn't it? Do you agree? Very important information, right? If I say I cap dot J cap, J cap dot J cap, this is going to become J square. And what is the magnitude of J? So this is a unit vector, so it is 1. Now similarly, K cap dot K cap, this is going to become K square. That is going to be 1. That is going to be 1. Do you agree or not? Yes, sir, absolutely. Now please think if I vector is multiplied with J vector, I and J multiplied. So if we multiply these two, what is going to happen? What is going to happen? Can you answer me? What is going to happen? Hmm? What is going to happen? So, sir, this will become 0. How come, sir? How come? Because lastly, we have seen if two vectors are at 90-degree with each other. So, if this is A, this is B, and this is 90 degree. This is 90 degrees. So, the dot product of this will become how much? The AB cos 90 and cos 90 we know it is 0. So two vectors perpendicular to each other, if you do the dot product of them, it is going to become 0. Right, sir? Absolutely, sir. We know that. Isn't it? Okay, so if I multiply I cap dot J cap, it will become 0. So this is going to lead to you a very, very beautiful thing. Okay, J cap dot K cap, this is going to become 0. And similarly, I cap dot K cap, this is going to become 0 because these are orthogonal vectors. So we know I, J, and K. So these are orthogonal unit vectors. So that means they are perpendicular to each other. Okay, so this is something that you must be take care of, right? Now see this property and what we have learned, the special cases, this can lead to many things. So see, I'll just give you something. So now if I say two vectors are added, A vector plus B vector. So if two vectors are added, the resultant is R vector. The resultant is R vector. So now we have law of triangle, we have law of parallelogram to get this resultant. Okay. But if we want to apply this Cartesian or the dot product thing, can you derive me this thing? R is equal to root over A. So we know, sir. We know it is A plus B plus 2AB, A square plus B square plus 2AB cos theta. This is the expression. But if we want to derive it through what we have learned, can you try it? Can you try it? Can you give it a try? Yeah. How can we try it? Let me do it. Let me do it. Just wanted to show you something. So now see how we can come up to this. So if I say, so I need R. So this is also like, I can write it like this: R square is equal to root over A square plus B square plus 2AB cos theta, right? A square plus B square plus 2AB cos theta. So can I write it like this? So R dot R, okay? Obviously, this is R square, okay? We just have learned that two vectors when multiplied with itself, when a vector is multiplied with, when a vector is dot product with itself, the vector dot product with itself, it is going to become the square of the magnitude. Now, can I write this also? So R vector is A plus B vector, A vector plus B vector, and this is again A vector plus B vector, A vector plus B vector. Okay. Now, see, the dot product follows distributive law. So can I write this? See, A vector, it will become A square plus A vector, B vector. So it will become 2AB, no? 2A vector, B vector, 2A vector, B vector, and B square, isn't it? Very simple. Right, now it will become A square plus B square plus, what is dot product of A and B? So the dot product of A and B, it is 2AB cos theta. Now same way you can again get the law of parallelogram of vectors, isn't it? Please answer me. Okay. Please answer me. Yes or no? Wonderful. And this thing also we come to understand that how to deal in the orthogonal unit vector. So can I say this is dot product of orthogonal unit vector? So see, what thing is you need to keep in your mind? So I cap dot I cap. Okay, that means when two orthogonal vectors are multiplied with itself, or an orthogonal vector is multiplied by itself, it leads to get you the unity. I square is unity. Okay, the magnitude of unit vector is 1 always, so 1 square is again 1. But when a unit orthogonal unit vector is multiplied with another orthogonal unit vector, like it likewise ij, jk, ik, so in those cases what happens, that the product will become 0. So dot product of the orthogonal vector is also clear, right? Right, now see, if I give you, so dot product, let us give it a heading. Dot product, very simple, very useful concept. So dot product of two vectors in Cartesian. So if two vectors are given to us in the Cartesian form, if two vectors are given to us in the Cartesian form, what is going to be the dot product of theirs? So A vector is equal to, let's suppose it is ax I cap plus ay j cap, okay, plus az k cap. And similarly, B vector is going to become bx I cap plus by j cap plus bz k cap, right? Okay. Now, if I want to do the dot product of these two vectors, let us say A dot product with B. So if I want to do the dot product, see, all you have to do, see if you, so vector follows the distributive law, but you don't have to write it. See how you are going to, so you can write AXI into BXI plus AXI into BYJ plus AXI into BZK, but why we are going to do that? Very good evening, Manoj. How are you doing, my dear? Okay, so now in this case, what is going to happen? See, we know I dot I will become 1. Okay, we know J dot J will become 1. We know K dot K will become 1. I dot J will become 0. I dot K will become 0. So see, all you have to do, you simply have to multiply. You simply have to multiply the I components together. You simply have to multiply the j components together, and you simply have to multiply the k components together. So see, it will become ax bx plus I cap will become 1 AY, BY. So J cap will become 1. Okay. And AJ, BJ. Okay. So K cap will become 1. So this is going to become how much? This is a scalar quantity. So we know two vectors, when they are given, they are having the dot products, you are going to get our answer as a scalar quantity. The same way you are going to get, okay, this I, J, K, everything will be gone, isn't it? Okay, very simple, very simple. Yes or no? Now let's move forward. So let's try one question here. So let's suppose the vector A is 2I cap plus 3J cap plus 4K cap. Okay, and B vector is 3I cap, okay, plus 2J cap minus 4K cap. Can you give me the dot product of A vector and B vector? Please get me the dot product of A vector and B vector. Please try to do that. I'm very sure we can do it. Please go for it. Very simple. Please think carefully. She's saying, I think we missed something. No, still you have missed something, beta. So see, so simply, see, this is very simple. So we have A vector, B vector. So I can have the I components multiplied together. So this will become 6 plus 6 and minus 16. Okay, so this will become minus 4, right? Not 4. Okay, okay. So the dot product of A and B is minus 4. Did you get it? All of you? Now let's try one more question. B ma beta, it is minus 4. See, very simple. Na? No burden on mind, no stress, no pressure, isn't it? Now let's try this question. So these kind of questions are asked a lot. Let me write this question. Very good, she's saying. Bima, you also try to answer it. Very simple question. Very simple question it is, isn't it? So see, very simply we can do it. So how we can do it? Bima, are you trying this question? See, work done is a dot product of force into displacement vector. Okay. We know work is a dot product of force vector and the displacement vector. Okay, so now a particle moves from position this to position this. So let's try to draw this one. So we have this as X, Y, and Z, and this is the first position. Let's suppose A, and this is the final position. Let's suppose B. Okay, let's suppose B. So this is going to be the displacement vector. Okay, AB vector. Okay, this is your displacement vector. So can I write work is equal to force into displacement vector, that is AB vector. Okay, so we can find this AB vector. So what we have learned, so this is the displacement vector, isn't it? So displacement vector AB vector is going to be the final position vector, that is OB vector, minus initial position vector, that is OA vector. Right? So what is this OB vector? This is 14. Now see, let's directly do it. So 14 minus 3. See, 14 minus 3, because see, we know when two vectors in Cartesian are added or subtracted, see, things will must be in your like fingertips. Okay, so when two vectors in Cartesians are differentiated or added, simply you can differentiate or add their I, their j, and their k components. Right? You can simply add or subtract their I, j, or k components. So 14 minus 3 will become 9. Okay, so I can write 9 of I. Okay, are you getting my point now? Very good, Bima. And then 13 minus 2, that is 11 of j. Okay, oh, 14 minus 3 is 11, sorry, not 9. 11 of I, so this is 14 minus 3, 11, then 13 minus 2, that is 12, then, sorry, 13 minus 2, that is 11, and 9 minus minus 6, so it will become 9 minus minus 6, so that is 15 of k. So this is going to be your displacement vector. Okay, now I can have the dot product. So force is given. What is the force? Force is 4 I cap, okay, plus j cap plus 3 k cap, okay, and this is into, so this is AB vector, that is 11 of I cap plus 11 of j cap plus 5 of k cap, okay, 15 of k cap. Okay, 15 of k cap. So this will become 44. See, I and I components multiply. So 44 plus 11 plus 3 into 15, that is 45. 3 into 15, that is 45. So it is 100 joule, right? Now let's move to the next question. Very, very simple, right? So find the value of m, find the value of m so that the vector, find the value of m so that the vector 3 I cap, okay, minus 2 j cap plus k cap may be perpendicular, may be perpendicular to the vector, may be perpendicular to the vector 2 I cap, okay, plus 6 j cap plus m k cap. And here you have some options as well. That is 12. Okay, B is 6, C is 36, and D is 80. Let's go for it. Let's try this one. I'm very sure we can do it. Please go for it. Please try it. How we are getting? So we are getting, yeah, wonderful. So find the value. So Bima, you also please try it. I'm very sure we can also do it. Please go for it, Bida. So which language are you guys are speaking sometimes? Just out of curiosity, I want to know. This is what language? Acha, acha. Okay, okay, okay. Wonderful, wonderful. I didn't know that. Yeah, yeah, yeah. Yeah, we must help each other always. So see how we can do it. So simply see, few things must be in like in your thumb, at your fingertips. Okay, two vectors perpendicular to each other, the dot product of theirs will be zero, right? Acha, she's saying, good, 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 beautiful place, no? I haven't been there. I always want to. Okay, let's see. At someday I'll get a chance to visit there. But I heard it is beautiful, na? Heard and seen like on digital media and all this. Okay, anyway, so let's come to the point. So we have, let's suppose, two vectors. So one vector is 3 I cap minus 2 j cap plus k cap, and B vector is 2 I cap plus 6 j cap plus m k cap. Now, if we are going to, so what is written, sir? If these two vectors are perpendicular, so the dot product of these two is going to be 0. Okay, so the dot product is going to become 0. So it will become 6 minus 12 plus m is equal to 0. So from here, m is equal to 6. See how? Just I to I, j to j, and k to k. Simple. Okay, now let's try one more. So let's suppose we have a vector a1 I cap plus a2 j cap. So it is a unit vector. It is a unit vector. It is a unit vector. Hmm. Yeah, yeah, Shweta. I heard about it. Very unfortunate. Unfortunate. Okay, but see, it is time and I'm very sure it will pass by. And hopefully soon you are going to get a medical college. So afterwards, then obviously you can contribute in all those things, right? What is this floating lake? See, I'm always fascinated about like those, beauty because I also live like Roorkee. It is also a like hilly terrain, right? Very nearby we have so always like mountains and everything, beautiful place, good environment. Okay, can anyways, let's come to the point. Otherwise, we start discussing all these things. So the other students who may watch the recording later, so they will feel that don't teach. Okay, I'll definitely search for it. Okay, let's try this one. Let's try it. I'm very sure we can do it. Please go for it. Please go for it, Buddha. See, very, very simple question. What about you, she's saying? Oh, sorry, what about you, Bima? Please try answering it. So you have to keep few things in your mind, right? What are these things? So A1I plus A2J is a unit vector perpendicular to this. If, okay, perpendicular to this. So two vectors are perpendicular to each other. So their dot product is going to be, so A1 I cap plus A2 J cap, okay, dot product with 4 I cap, okay, minus 3 of J cap. So see, they both are perpendicular to each other, okay. They both are perpendicular to each other. So when they both are perpendicular to each other, that means their dot product is going to be 0, isn't it? Their dot product is going to be 0. So if their dot product is going to 0, it will become 4a1. Okay? 4a1 minus 3 of a2 is equal to 0, isn't it, beta? Right? Is it or isn't it? Wonderful. Okay, so this is one equation. So in this equation, so I always keep telling you, na, like whenever you are solving the equation, if there are two variables, you need to make that two equation. Two variables can be easily solved. So this is one equation. Now what is the other equation? So what other information is given? So A1 I cap plus A2 J cap is a unit vector. So what is going to be the magnitude of it? The magnitude is going to be 1. If this is your A vector, let's assume if this is your A vector, now magnitude of this A vector has to be 1. So can I write root over, what is the magnitude? Root over A1 square plus A2 square is equal to 1. So that means A1 square plus A2 square is equal to 1. A1 square plus A2 square is equal to 1. Isn't it? Can we write like that? Isn't it? Please answer me. Okay. Okay. So now we have two equations. Okay. Two equations. So we can obviously solve two equation, two variable. Isn't it? Like from here we can write the value of this A2 or A1. A1 is 3 times A2 by 4. 3 times A2 by 4. We can put it here, then we can find this A2 value. So when we do it, we'll be getting solving this equation. So I hope that you can solve this equation. So point A, just to save some time, because I want to continue to, till the vector product today. Okay, I'm trying to take, much more concept today, because see, I want to finish the vector now. Okay, so that we can continue, because see, I'm going with the 75-day challenge also. Now it is challenge for me that what question I give you. Okay, because see, vectors, you don't get the questions of vector directly a lot, though its concepts are very useful, and sometimes you are getting direct questions also, but this is necessary to learn. Okay, so before we move to the kinematics, before we move to the Newton's law, vectors was the must. Okay, okay. So I'll be finishing it now very soon. Yes, I'm also trying in the same way, but I cannot leave anything now. Yes, that is also something that we have to be careful. Okay, so this is clear now. This is clear. Now let's start. So we can have some more questions, but let's start with the concept. Okay, so finding angle, because we are moving ahead with the session of this 75-day challenge also. So we can see some questions there too if we require. So finding angle between two vectors. See, this is a very, very important concept. Okay, very, very important concept. Okay, so today I could have done some questions using this also, but see, like I haven't taught it. So now very, very simple. So we know that the dot product of two vectors is AB cos theta. Okay, so this cos theta is going to be the cos theta is going to be A vector by B vector into B vector, that is dot product into B vector upon A mod or B mod. So I can put like this also so that we don't get confused. Right. Very simple, sir. Very simple. So, sir, what is the requirement? We already have knew it. So, see, you must understand that where we can apply, where we can apply this very concept. Okay. Okay. So, see, dot products of two vectors, that is A vector dot B vector, it is going to be AB cos theta. Okay. Now see. So, what kind of a questions can be asked? So, if say it says that A vector is I cap plus j cap plus k cap and b vector is minus 2 or of I cap minus 2 of j cap minus 2 of k cap. Now if I ask you what is the angle between these two vectors, how you are going to answer it? Yeah. I'll give questions here. Every day we are doing questions, na? Don't worry. And after the vector is completed, we are going to, increase the speed also. Okay, because see, this is something, so many things are there, na? So many rules, so many things. Okay, now let's try this one. What is going to be the answer? Nima, you have to also solve this. 180. Yeah. See, very, very simple. Sir, A vector we have, B vector we have. What is going to be theta? So, sir, we know cos theta is equal to A vector dot product with B vector upon A B. See, in the questions of vector, this is also like very, very, interesting to know that if a question is asked, so one question you can solve in various ways, right? Okay, now which way is going to give you the best result in the least time? That should be the approach. So we have A vector, B vector. So what is going to be the cos theta? So dot product of A and B. So it is going to be how much? It is going to be minus 2, and minus 2, isn't it? Okay. Okay. So upon see what is going to be the A mod of A, it is going to be 1 square, 1 square, 1 square, that is root 3. Okay. And this is going to be root over. So 4 plus 4 plus 4, that is 12. Okay. That is 12. So basically, see, it will become minus 6 and this will become root 3. And what is 12? So it is 4 into 3, that is 2 root 3. So root 3 will become 3, 3 into 2. So it will become -1. So theta will become 180 degree, right? Theta will become 180 degree. So let's quickly do one more question. Okay, get me the angle between these two. Please go for it. What is the angle between these two vectors? What is going to be the angle between these two vectors? Can you try to give me that? What about you, Bima? Can you please answer me this? What about you? So we have here A vector and B vector. We have here A vector and we have here the B vector. Okay, A vector and B vector. Okay, so now see, sometimes like in hurry we make a mistake here. So see here in this what happens. So see I plus J and J and K. So see when we are in hurry or sometimes when we are in pressure, what we do, so we see I, J and J and K. Right? So be careful with what you are doing. Okay, so we know, so cos theta is equal to A vector dot B vector upon mod of A and mod of B. So A vector, B vector, so this will become C. So here can I write 0 I cap, okay, and here I can write 0 K cap, okay. So only J and J are there, na? Only J and J are there. So it will become 1 right away. See I with 0, I and 0 I, okay, then J and J, then I K J K, so it will become only one. Now what is this? So this will become root 2 magnitude of A, and what is the magnitude of B? It is again root 2. So this is going to become 1 by 2. So theta will become 60 degree. Yeah, yeah. Yeah, we must learn the question. Or but see, she's saying how many questions are there in the NEET examination? Just let's discuss something. How many questions are there in NEET examination? Meanwhile, you answer me that, I'll just get you another question, another concept. Let's move to, so let's move towards the concept. So these are very, very similar concepts. See, it is also a challenge that it must come in your mind right at a right time. Okay. Now, overall, how many questions are there? All subjects. All subjects. 200. Out of which we have to do 180, if I'm not wrong. Okay. Now, in each of the question, so see, if we start like a question is like this, see how many words? 1, 2, 3, 4, 5, 6, 7, 8, 9, then equation 10, 11, 12, 13, 14, 15, 16, 17, and the options. Okay. So, if we consider 20 words for the very least, 20 words for the very least in each question, 20 words multiplied by 200. How many words are there in the whole paper? Can you tell me that? Just basic calculation. How many words will be there that you have to read in a NEET examination? Hmm? 200 into 20. That is 4,000. Isn't it? Okay. Now, when I say 20 words, so this is the smallest question. So if we multiply it with by a factor of something, like taking some margin, so 6,000 or 8,000 words you have to read in the duration of the NEET examination. Okay. Now, ever try reading? So if you take like, if see, we have to increase the speed of understanding of, we have to train our mind like that. See, competition is a different business. Are you getting my point? So when we're reading so many words at a time, okay, and you need to then process the information, you need to process the approach. So we have to train our mind. Huh? So you have to train your mind that we have to see. You cannot spend a lot of time in understanding a question. Are you getting? That is why I see sometimes I also read the key points of the question and go answering. Right? So this will happen with practice, but you consider this in your mind that see, this is not absolutely wrong. So we have to take the information from the question also at times so that we can save some time in the examination. Okay? Okay. Let's move to the next topic. So angle made by a vector with coordinate axis. Okay. So we understand that the coordinate axis is very, very important, isn't it? Now, if we have, let's suppose we are having, see, what I'm trying to ask you here, let's suppose we have three axis system, okay, X, Y, and Z. Bima, if you have any doubt, beta, you can please ask me, huh? Please feel free to ask me doubt at any point of time, okay? Let's suppose this is vector A. Let's suppose this is vector A, okay, and it has some, coordinate like AX, I, or I'll write it here. So let's suppose we have a vector A and this vector. So we know, I think we are very much handy to it now that it can be presented in Cartesian like this. So we have AXI, then AYJ cap plus AZ K cap, AZ K cap. So this is your vector. This is your vector. Now what I want to do here is I want to find the angle this vector is making from each of the coordinate axes. So we learned to see the angle between two vectors. Okay, what is the angle between two vectors we just have now seen? Now I want to see what is the angle this vector is making from each of the coordinate axes. Each of the coordinate axes. So let's see. See. Now if I see with respect to x, let's suppose this is alpha. With respect to x, let's suppose this is alpha. Now what is this ax? If I write this ax, this is your ax, right? This is your ax, right? The component of a in the direction of x, the component of a in the direction of x. Now, if I want this alpha, see, can I do like this? The cos alpha is equal to ax upon a. Do you agree or not? Please answer me. Sir, how come, sir? So we can see clearly a triangle. We can see clearly a triangle. So in this triangle, this is base, this is hypotenuse. So the magnitude of a vector, okay, that is the length of this a na, that is the length of this hypotenuse. So this is alpha. So this is the alpha is the angle that this vector is making from x-axis. Now similarly, if I want to find the beta, so what is this beta? So beta is the angle. Beta is the angle that this vector is making from the y-axis. And I hope you believe this. This is your ay, na? The component of this vector in the y direction. The component of this vector in the y direction. Now you can see, you can have a look into another triangle. So this ay is the base, okay, and again a is the hypotenuse. Again a is the hypotenuse, okay. So this is the beta. This is the angle that this vector makes from the y coordinate. And similarly, sir, if we want to see from Z. So let's suppose this makes an angle of gamma with Z axis. So it will become AZ upon A vector in the same pattern, isn't it? Isn't it? So see, you must have, you must have observed a pattern. Okay. If you have a vector with its x, with its I, j, and k components, you can right away get the angle. You can right away get the angles of the angle. You can right away get the angles that the vector is making from x, y, and z coordinate. Understood, beta? Please answer me. Yes or no? Yes or no? Okay, so it is very simple from the coordinates. So see, that is why Cartesian is so, easy. So if you have a vector written in the Cartesian format, right away you can find the angle that vector is making from each of the. So gamma, see, I haven't shown you gamma because this is a three-dimensional system, na? So see, so first of all, what is the z-axis? Can you think of the z-axis practically? What is z-axis? So z-axis is this, na? If you see, use your right hand one. Use your right hand one. Okay. So we are about to reach to the cross product. There you will be having to use the right hand thumb rule very soon. So use your right thumb. See, this thumb is your axis. Thumb is your axis. So when I say x-axis, this is your x-axis. Huh? When your palm is facing you and thumb is pointing like this is positive x-axis. Yes or no? This is y-axis and this is your z-axis. This is your z-axis. Now see a vector. This pen, let's suppose, is a vector. See, when this plane is two-dimensional. So now this is your what axis? This is your vector. I have just placed it to some incline like this. And now this is your z-axis. This is your z-axis. Now use this. You must have got a pen. Use this. Use your thumb as the z-axis and this vector. See. And I don't know if we are able to get it from what I'm trying to do here. But if you try to do it yourself, you will definitely get an idea that how the Z axis makes an angle with A. Okay. Okay. Clear? Right. So simply we can use this formula. Okay. So see, that is why if you have observed the pattern, so we learn things in two dimension, then we use the same context in three dimension. So why it happens? Because see, our books, our yes, huh. So in our books, in our the screen and boards, whiteboard, blackboard, whatever we are having is 2D. So that is why normally physics is taught in two dimension, and then we use the same concepts in three dimension. Okay, using our imagination. Okay, because we are not using this three dimensional board or something, right? Okay. Now moving ahead. So let's say the angles which are vector, the angles which are vector I cap plus j cap plus root of 2k cap makes with x, y, and z axes respectively are. Bima, you also, I want you to better give the answer. See, if there is any doubt, see, don't feel like any doubt is, small or big. You always ask to me. Okay. So we are there to help you only, beta. Please do that. Please do that. Your feedback. So let me have some water. Please do that. So what are we getting? So it says the angles which a vector I cap, j cap plus root 2 k cap makes with x, y, and z axes respectively are. So we know, sir, cos alpha, alpha is the angle made by the vector from the x-axis. So this is going to be 1, see, ax upon a mod. So what is this? So right away, see, we can do 1 upon, so what is a mod? Or what is the magnitude of this vector? So 1 square plus 1 square plus root 2 square. So that is 2. Okay, right. See, we have to save the time. Okay, we have to save the time. So 1 plus 1 plus 2. 1 plus 1 plus 1 plus 1 plus 2, that is 4. So root over 4, that is 2. Right? So this is going to be 1 by 2. So alpha is going to be 60 degree. Now cos beta is equal to ay. See, right away it must come into your, like, you read the question and immediately you start doing it in your mind, or doing it like in your copy or anywhere, right? So cos beta again 1 by 2. So this is going to be beta is equal to 60 degree. Again beta is going to become 60 degree. Now we have cos gamma. So cos gamma, this is going to be root 2, okay, upon magnitude. So magnitude of A is 2. So 1 by root 2, 1 by root 2, that means gamma is going to become 45 degree. Gamma is going to become 45 degree. I hope it is fine to everyone. Right? Okay? Okay? So this is going to be the C option. Right? Okay. So I hope that you will be able to deal with these kind of a things. So let's me move to the next concept. Now be very careful with this concept. See, okay, so shall I give you? Okay, I'll give you one more concept. Let's see if you can grab it or not. Now, see, as I said, in vectors, there are a lot of ways to do a certain thing. Okay, now let's see this. So, component of vector B along vector A. Alright, sir, we already have done this now. Let me show you something. So, let's suppose this is your vector A. Okay, this is your vector A and this is your vector B. Okay, this is your vector B. And this is angle theta. This is angle theta. See, this will save a lot of time in the examination. Yeah. See, this is like, see, they can come directly also and they can come in the form of another concept. So if you are handy with all these tricks, all these things, so see what is going to happen, my dear, you are going to have save a lot of time. And time is very crucial in the competitive examination. See, now see, I'll show you one more trick. So if there is a vector, there is a b vector. If you want to have the component of b vector along a vector, now I think you believe me that in physics this component thing has a lot of use. Now resolution, taking components and all things are given in vector. So many things are there. Now see, sir, we know it's what is the vector? What is the component of vector b along a? Now please understand this. So, sir, we did it before also. So why you are showing us again? I don't understand. I'll show you. Now, first of all, let's say, so this component of b vector along a vector is b cos theta. Do you agree or not? And this is a scalar component. B cos theta is a scalar quantity, isn't it? Because see, when we are taking the component like this, okay, we are using the magnitude of b. Okay. Now from here, cos theta we just have seen. So this is b, and cos theta is what? Sir, a vector dot product with b vector upon a b, okay, upon a mod b mod, isn't it? Okay. Now, can I cancel this B and B out? Because B is the magnitude now. And can I write it like this? Sir, B, because it is commutative. So B I can write here, and A cap upon A vector upon A is nothing but A cap. Isn't it? Isn't it? Please answer me. So when you are writing the component of B vector along A vector, you can write right away that vector b into vector b dot product with a cap, that is the unit vector, isn't it? And remember guys, this is an scalar quantity, this is a scalar because theta is a scalar na. So this thing is a scalar thing. Do you agree or not? Please answer me. Believe the component somewhat. The projection concept somewhat is related to this, but let's not go there right now because it is going to be a little complicated. So let's focus on this, otherwise you will get confused. Okay, so this is first of all a scalar thing. So when you are finding the component of any vector along another vector, yeah, don't worry. See, every teacher has his own pattern of teaching. Okay, we cannot say some teacher is good or someone is bad. He might have a different vision. Normally, many teachers don't teach all this. In vectors, I don't think if you search the whole YouTube now, I think very less teachers are teaching vectors in this much detail. They normally make one shot or like two videos of vectors, and they tell you like some basics of parallelogram, vector addition, vector subtraction. This is what I usually see, right? They believe that this Cartesian thing will happen to be alongside, or they believe that the Cartesian thing students are knowing beforehand. Okay, but I prefer to teach this. Each teacher has his own way, right? Okay, now remember this is a scalar. So when you are finding the component of any vector along another vector, you can simply write that vector into the unit vector of the A vector. But remember, this is a scalar thing. This is a scalar thing. You are taking the dot product. Now, similarly, if I ask you, like right away, I want you to write component of A vector along B vector. Component of A vector along B vector, what it will be? Component of A vector along B vector. So very simply, sir, in same pattern, we can write component of A vector along B vector. So it is A vector dot product with B cap. Okay. So this is going to save a lot of time when you will be, so see, again, when you see the NEET PYQs, you are going to see one kind of a question very frequently asked, and that is it. This, see, the component of vector. Let me merge a few questions. So component of vector A, let's suppose A vector is 2i cap plus 3j cap along the direction, along the direction I cap plus j cap and I cap minus j cap. Okay. So obviously you will have some options. So let's suppose in the solution, see the options. So options are there which having all the scalar quantity. Then you can use this concept. Okay. If in the, I'll tell you one thing. So these kind of questions, when you are going to see in your previous year questions, you are going to see the options where options are having the scalar quantities, and you are going to see the options in which the options are having vector quantities. Okay, so I'll tell you how to see that vector thing. But if the options are having a scalar quantity, you can go using this concept. Please, can you please try it? Can you please try it, both of you? Can you please try it? See, when you see if this is if you question see this question, if you may see this question in the pattern of the NEET that follows, so in that the options, all the options are having the scalar quantities in both the cases. Something is missing. What about the rest of you, beta? What about the rest of you? Yeah, that is the correct answer. Now, what does it say? So it says the component of a vector, that is a vector, is equal to 2 I cap plus 3 j cap along the direction this and this. See, and you need to get the scalar option. So we have a vector along this direction. So how we can do it? So let's suppose in case one, a vector is 2 I cap. See, it is very simple. Just a small thing you have to keep in your mind. 2 I cap plus 3 j cap. Okay, 3 j cap. So what it is going to be? So now component of this vector in the direction of b vector, let's suppose I cap plus j cap. So don't get confused. This is a little confusing. Please understand this. Now see what happens when you see the component of this, component of a vector along b. When you are going to see the component of a vector along b, so what is going to happen, sir? We can write a vector dot product with b cap. Remember this dot product. See, at times what happens is student thinks that a vector then dot product of b vector. Not dot, they forget about the dot. Then they think that this is the direction. No, this is not the direction. This is a scalar quantity, na? So this is basically the magnitude of it, na? This is basically a magnitude of it. isn't it? This is basically the magnitude. Now please understand this. So what is going to it? So it is a vector. So a vector is 2 I cap plus 3 j cap. Okay, 2 I cap plus 3 j cap dot product with the b cap. So b cap is b vector, that is I cap plus j cap upon mod of b. So mod of b, that is root 2. This is going to be the b cap now. Okay, unit vector is the vector by its magnitude. Okay, so it is going to be, see, 2I square. So it will become 2 plus 3 by root 2, right? Dot product of two vectors is always a scalar. So this is going to be 5 root 2, isn't it? So this is the magnitude, remember. This is the magnitude, remember. Okay, no scope of confusion. Now again, A is this, okay, 2I cap plus 3j cap, okay, and B vector is I cap minus j cap, right? Now in this case, what is going to happen, beta? Now in this case, yeah. See, I'll just tell you something. See, 100% focus is there. See, many times I have told you this. This is magnitude. This is magnitude. This is magnitude. I'll just give you a twist in this. Okay, so A vector and B vector are there. Now, what is the component of A vector in the direction of these? So, see, A vector, then dot product of the B. See, this way, see, you can save a lot of time in the examination. I'll tell you. Today, I could have solved a few questions of this concept, but if I give it to you today, then definitely you will be having some confusion. So, mostly tomorrow we'll come up with some concepts like this. Okay. So 2 I cap plus 3j cap, and what is this b cap? So this is going to be I cap minus j cap upon mod of b. So this is root 2. So what it is going to be? It is 2 minus 3 by root 2. So this is going to be minus 1 by root 2, right? This is going to be minus 1 by root 2. Now again, this shows the magnitude. Now remember, this shows the magnitude of the component of A along the B. The component of A along the B. Is it clear, my dear? Please answer me. Right? Please answer me. Hmm? Right? Now, please tell me if this is clear up to this point, because I want to give you what something very, very new and it's a little confusing. Wonderful. So now please think. So what we were doing, so we had, let's suppose this B vector, let's suppose this is I plus j. Just let's proceed with the same question. So it is I plus j cap. Please listen to me very, very carefully at this moment. Now this is your A vector. This is your A vector, and this is theta. This is theta. Now please understand this. Please understand this. So when I take the component of this A vector along the B vector, A vector was what? So this is 2I plus 3j. Now, tell me one thing. This component of A vector along the B vector, is it a vector or is it a scalar? Please answer me. So when you are taking of this component, when you're taking the component here, so basically you have given, so for this question you have given this is 5 by root 2. Okay, A cos theta or A b dot b cap. So this is 5 root 2. This is the magnitude of this vector now. But this must have some direction. This must have some direction also, because see, our component of a vector is a vector only, isn't it? And vector has two things: magnitude and direction. Now, if I say that this component of this A vector along the B vector is a vector of magnitude 5 root 2, 5 root 2. I think that is going to be fine to you. And what is going to be the direction of it? So the direction will be B cap. Are you getting my point, beta? Are you getting my point? So this is going to be the vector component of a vector along another vector. Are you getting my point? Uh, Shreya, okay, beta. I'll try to. Okay, so what we are doing here, beta? So we are talking about the component of a vector along another vector. Okay, okay. So here the component of this vector A, okay, along the B in the vector form is going to be 5 root 2 B cap, because B cap is going to give you the direction of this vector. Are you getting my point? So please understand this. It might be confusing. So vector component, see vector component of a vector. See vector component, let's suppose vector component of A vector along B vector. Okay. Vector component of A vector along B vector. So what it is going to be? So it will be A vector dot b cap. Okay, so this is the magnitude, remember. So any vector has magnitude and direction, and the direction will be given by b cap. Now see, this funda that you have to use, so don't make it b cap, b cap, b square. Are you getting my point? See, this is one thing, this is the magnitude. Are you getting the clarity in this or not? This is the magnitude and this is the direction. Are you getting my point? Please answer me. This is the magnitude and this is the direction. Okay, is it fine? Okay, now similarly, if I ask you that what is the vector component? What is the vector component of B vector along A vector? Along A vector. So again, it will have both magnitude and direction. So what is going to be the magnitude? Magnitude is going to be V vector dot product with A cap, and direction is going to be A cap. Direction is going to be A cap. Right? Now, if I ask you in this question, in the same question, let's suppose this one. So, see, A cap is 2I cap plus 3J cap. Okay. And B vector is I cap plus J cap. Now, find component of A, find component of A, find component of A vector in B vector in vector form. अगर vector form में निकालना हो तो how you are going to do that? Please answer me. Let's go for it. So basically, see, this is, so firstly you have done the dot product, then scalar into vector. A cap, B cap is a vector, and this is a scalar. Okay, this is a scalar quantity. So final scalar multiplied with vector is always a vector. Right, Buddha? Now please do it. Can you please try it? So here you have to give the vector form. Please go for it. Very good. What about the remaining of you? Shreya, Sai, Bima, please answer me. What about the rest of you? So see, very simple, sir, very simple. So we have two vectors. One vector is A, one vector is B. Now we have to find component of A in B direction in vector form. Okay. So how we are going to do that? How we are going to do that? So see, first of all, so we'll be getting a vector, and the magnitude of that vector is going to be A vector dot B cap. Okay, this is the magnitude of this vector. You can separate it also. So what is going to be the magnitude? So A vector. So this we already have done 5 root 2, isn't it? 5 root 2. Now, what is going to be the vector? Let's suppose that component is given by v vector. So, what is its magnitude? It is 5 root 2. And what is its direction? So, it will always obviously be in the direction of b. And the direction is given by what, beta? Direction is given by the unit vector. So, what is the direction of b vector? It is b cap. So this will become 5 root 2. This will become 5 root 2 into b cap. So b cap is going to be I cap plus j cap upon root 2. So this is going to be 5 by 2 I cap plus j cap. Okay, clear? Isn't it? Okay. Now do you want to do one more question of JEE? Little more interesting. Do you want to do it? Or are you comfortable with this concept? Okay, let us do it. No worries. I'll have to write it. So given two vectors, A cap is equal to 3 I cap plus 4 J cap, 4 J cap, and B vector is I cap plus J cap, and theta is the angle between A vector and B vector. A vector and B vector, which of the following, which of the following statement is oblique R correct? So is oblique R correct means this is multi-choice question. That means it can have more than one correct option. Okay, MSQ, sorry, multi-select question. It is a mains question. Just a moment, huh? I'll write it. Okay, let's try it. Take some time, beta. Ah, please do that. Please answer me. Please say no. Please think again. See, this is a very interesting question and very good question at the same time. So let me do it. So it says given two vectors A and B. So we have two vectors, A vector and B vector. Theta is the angle between A vector and B vector. Which of the following statement is and are correct? Which of the following statement is and are correct? So see how we are going to have it. Now we have A vector and we have B vector. So see, first of all, the vector component, the options you can see from the options that, so the options are given in the form of vector. So that means, sir, we have to get the vector component of a vector along another vector, isn't it? Haha, I'll come to that. You forget. See, this is C. She's saying, I'll tell you one thing. So in physics, what happens, Nabita? Like nothing is difficult. The difficulty is that at the right time, right concept is coming in your mind. That is the difficulty. Are you getting my point? Okay. Huh. So that you are doing from the common sense. Yeah. If D is not the answer, then B is obviously the answer. Okay. So see, we don't have to do that way. In the examination, we don't have this much choice. Okay. See, this will happen with practice that the right concept will come right at that time. Okay. This is the challenge. That there's nothing difficult in physics otherwise. So given two vectors, A vector and B vector, theta is the angle between these two vectors. So I was saying that first thing is clear in our mind. That's the, yeah, don't worry, I'll tell you. So very simple, just a small thing. Okay, very simple. So see, given two vectors, A vector, B vector. So first of all, here the components are asked in the vector form. So we need to do the concept. So component of A vector in the direction of B vector. So let's call it C vector. Let's call it C vector. So C vector is going to have a magnitude, and what is going to the magnitude? So A vector dot product with B cap, and what is going to be the direction of it? Okay, so here see the options are given in terms of theta. So what concept? Cos theta concept you have to apply. So let's make the figure. So here we have a A vector, and this is, let's suppose, your B vector, and this angle is theta. This angle is theta. Now please understand this. See, this is how the concepts are used. So A cos theta is clearly the magnitude. A cos theta is clearly the magnitude. Okay. So A cos theta is clearly the magnitude. So if I see the component of A in the direction of B, component of A in the direction of B, so this component, so what is the magnitude? It is going to be A cos theta. So this whole thing is the magnitude. And what is the direction, sir? It is B cap. Now B vector is given to you. B vector is I plus j. See, in this question, there is no use of this information that A is 3I plus 4j. Isn't it? Hello, Ankit. How are you doing, beta? So A cos theta is the magnitude and B cap is going to be the direction. So A cos theta, and what is this B cap? It is I cap plus j cap upon root 2. Okay? Okay? So this is the first option is clear. This is correct. And this is the easy part of it. Isn't it? Ankit, what we are doing beta here, so we are studying into the vector. Okay, so basically we are into the journey of this physics, and on this channel, I am the physics educator. I am Dr. Umashankar. I teach physics. Okay, so what we have done till now, so we have completed a chapter of units and measurement, and we are into this kinematics. So we are running two topics parallelly. One is motion in a straight line, and the second is motion in a plane. So for motion in a plane, we require some information of the vector. So we are completing the vector also. Okay. Okay. Now this is clear. Now please understand this. So now it says, so see, first of according to the options, my dear, this was easy, right? This was easy. Okay. That we wanted to have a vector component of a vector in the direction of another vector. So vector component of a vector will have some magnitude, will have some direction. We did it. Now we want the component of the vector in the perpendicular direction of this B vector. No, 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 no. No cross product, no cross product. Just listen to me. No cross product. See, tell me one thing. Tell me one thing. This B vector is I vector plus J vector. Now, graphically, let's suppose this is C. So this C vector is perpendicular to the B vector, isn't it? Okay, do you have any idea of dot product? So in today's session, beta, we are about to complete the dot product. This is the last thing of the dot product, and I'll be starting with the vector product as well today itself. Okay, the vector product, cross product, we are going to do today itself. Are you getting my point? Okay. Now C vector is obviously the vector perpendicular to the B vector, for very sure. If this is B vector, this is C vector. Now if this is I plus J, this is I plus J, can I write it I cap minus J cap? Or sir, how come you can say this is I cap minus J cap? Arey beta, the vector, the dot product of two vectors is 0 if their angle between them is 90 degree. Isn't it? अरे भाई दो वेक्टर्स के बीच का अगर एंगल 90 है तो उनका डॉट प्रोडक्ट 0 होता है ना. So if this is I plus j, this has to be I minus j, isn't it? Please answer me. If this is I plus j, this has to be I minus j. How come, sir? See, 1 into 1, that is 1 minus 1 into 1, that is minus 1. So 1 minus 1, this is 0. Okay, this is 0. Right. So what is this C vector? This is I minus J. Now when you want the vertical component, now see, what is the component in this direction? So this has to be A sine theta. And this A sine theta is obviously the magnitude. When you do the resolution this way, you always get the magnitude. Okay, so A sine theta is the magnitude. A sine theta is the magnitude. and I minus j is the vector. So what is the perpendicular component? What is the perpendicular component? So perpendicular component is going to be a sine theta. This is magnitude. And what is the direction, sir? The direction is going to be c vector. So sine theta is nothing but this. This is the magnitude, na beta? This is the magnitude only, right? So every vector has a magnitude and a direction, right? Now this is going to be c cap. So this is going to be a sine theta. What is c cap? Unit vector. So unit vector is I minus j cap upon root 2. Upon root 2. Okay, clear? Please answer me. Please answer me. No, here you don't have to. So this is correct only. See, don't get trapped into x, y, z here. Are you getting my point? Because I plus j is not in the direction of x now. So we just have assumed this vector to have in this direction. This is not x direction. This b vector is not along x direction. Is it along x direction? I plus j cap it is written now. Isn't it? So it is between that. So that way it becomes complicated. We just have assumed two vectors. Okay, because we are seeing the relative position of it. So interesting question it was. Now with this question, I think the concept of the dot product or the scalar product of two vectors will be crystal clear, isn't it? So we have all the twisted ways of understanding. So we have seen multiple ways of understanding it, and I think this is going to be very clear to you guys. Am I correct or no? Is it right or wrong? Yeah. Now I'm going to move up with the uh, I'm going to move up with the next concept of vector or cross product. Very important. Now let's move to vector or cross product of a vector. See, very interesting, very useful. And see, if you take care of some concept, then you will be very, very comfortable. So we'll be having vector or cross product. So see, very simple, very simple. So, like when I started with the multiplication of a vector of vectors, I told you two vectors multiplied may get a scalar as a result or may get vector as a result. So, if two vectors are having the dot product, this is the dot product, right? We get the scalar. Okay. Now, simply see when two vectors are multiplied. So see, this is not multi. This operator is known as the cross operator. This is dot operator. So vector A cross with vector V, cross product with vector B. Let's suppose we are getting a C vector. Okay, so see, this is a vector. This is also a vector. This is also a vector, and this is also a vector. So cross product of two vectors itself is always a vector. Okay, this is the basic difference, and this thing leads to many things further. Okay, so sir, why do we need the cross product? See all these things, all this vector is again helping us to understand the physics. Okay, and what is the language of physics? So the language of physics is the physical quantities. So, like the work done, which is so in work done, what happens? So, in work done, when we multiply two vectors, okay, work done is a scalar quantity. So, when we have the dot product of force, which is a vector, with the displacement, which is again a vector, we get the work done that is scalar. But there are some quantities like the torque, okay, this tau is torque. So when we are going to see the rotational mechanics, we will be talking about, see, simple. I'll tell you one thing. So force, torque is also a force only. So when the force acts on a body in a way that it gives it a linear motion, then it is a force, generally we call it. When we call it torque, so basically this is torque. See, this is torque. Okay. So if you have a force which have a tendency to rotate a body about its axis, that is torque. Okay. Okay. So mathematically or by definition, this is going to be displacement vector into force vector. The torque is going to be what? The torque is going to be the displacement vector into the force vector. Are you getting my point? Okay. So see, displacement vector into the force vector. So here this is the cross product because torque is also a force. So it has to be vector. It has to be a vector. So now two vectors when multiplied you are getting a vector. Okay. That means you are doing the cross product. Okay. So just give me a moment here. I'll take some water. just one moment. Huh? Yeah. This is a force which produces the rotational motion. Yeah. Let's me back. Now, remember one more thing that torque is not this. Okay, there is a slight difference, although it doesn't make much difference. But this is not this. This one is right. Okay, so remember the torque is the vector product of displacement vector into force vector. Are you getting my point? So what difference is it? So it is the difference of sign actually. Okay, but remember, okay, torque vector is the cross product of displacement vector and cross product of force vector. Okay. When displacement vector and force vector are having the cross product, you are getting the torque vector. So, sir, are they same thing? No, 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 they are not the same thing. Okay, there is a difference into it. Okay, we'll talk about it. Now, please understand this. Now, please understand this. So, see, a lot of things are going to happen here. Now, see, so what is A cross B? See, now we are going to be a little bit fast. Huh? So, this is going to be magnitude of A, then magnitude of B, and sine theta. Okay, sine theta. Are you getting my point, Vida? Are you getting my point? So basically, this is the magnitude. I'll talk about the direction. See. Now when I write, so I'll do like this. See, please understand this. See, so whenever you are doing cross product of two, you are getting a vector. Now again, for a vector, what do we require? So for a vector, we require both. What's the magnitude and direction, right? So we require this also, and we require the direction also. We require the direction also, isn't it? Okay, we require both these things. Okay, now when you are doing the cross product of two vectors, so what is going to be the magnitude? So I can write it like this. See, first thing that we are finding the magnitude, okay, or it is like this. So when we are finding the magnitude, so it will come out to be AB sine theta, AB sine theta, just like the dot product where we had the what, where we had the cos theta. In cross product we are having the sine theta. Very easy to remember, na? Okay, very easy to remember, right? Very easy to remember. Okay, understood. Now the second thing, what is going to be the direction? What is going to be the direction? Okay, now here there is a trick. Please understand this. Okay, please understand this. Now, what is going to be the direction of A cross B? So, first thing, now listen to me very, very carefully. Very, very carefully. So, I'll give you a few information about it first of all. So, the first information is, now remember when I said, so in the when I started with the vectors, I told you that whenever there are two vectors, they are always in a plane, isn't it? Two vectors are always in a same plane. Do you remember it? Hmm? Two vectors always in the same plane. Two vectors are always in the same plane. Are you getting my point? Two vectors are always in the same plane. Do you remember it? So the first thing, so definitely when there are two vectors A and B, these two vectors are going to be in the same plane. So first thing, first information that I want to give you here is direction of A vector cross B vector is going to be perpendicular to the plane of A and B vector. A and B vector both. Okay. Okay. So if at all, like for example, they always are to be in the same plane, but to have the clarity, see, remember this A vector and B vector both, so both are in the same plane obviously, but their planes, okay, so whatever plane is there, the direction of their cross product will be perpendicular to it. Are you getting my point, beta? Are you getting my point, beta? First thing, yes or no? Please answer me. This is clear. Now please understand this. So let's have a plane. Please think carefully. See, lately we are going to simplify it much further when we develop some formula of it. And second thing, so first information, this is perpendicular to the plane. So let's suppose this is a plane, right? Let's suppose this is a plane and vector A and vector B, these are two vectors lying in this plane, okay? And they have the angle theta. So when you are writing A vector cross B vector, okay, you have the magnitude of this, okay? Now we are to think about the direction. So see, if I say this lies in the same plane, so first thing is that the vector, this vector, this A cross B vector, the vector that you are getting from the cross product of A and B is going to be perpendicular to the plane of A and B. Okay. Now please understand this. So see, this is x. Let's in general, I'll give you something x, y, and z. So how many planes are there? How many planes are there? So three planes are there. X, y plane. So if two vectors are lying in xy plane, two vectors are lying in xy plane, what will be the direction of the cross product? So it will be in z direction because to xy plane z is perpendicular. Similarly, if we are having the vectors in yz plane, the cross product is going to be in x direction because x is going to be perpendicular to yz plane. And similarly, if something is in xz plane, okay, okay, the cross product direction will be perpendicular to xz plane, that is going to be the y direction. That is going to be the y direction. Okay, so this is clear. Now see, if we apply this thing here, so let's suppose that there is an axis. So to each plane, to every plane in the world, there would be one axis that is going to be perpendicular, that is going to be perpendicular to the plane. Okay, do you agree? Do you agree? So let's suppose this is the axis which is perpendicular to this plane. Okay, to this plane. But this can be, now see, what could be the direction? So definitely we understand that direction of A cross B would be either upwards or either downwards. Okay, okay, because we understood that it has to be perpendicular. The vector has to be perpendicular to the plane carrying A vector and B vector, right? So this is going to be the direction either upwards, either downwards. Now the question is, now the problem is that how we come to know whether it is upward or whether it is downward, right? Whether it is upward and whether it is downward. So for that beta, what we have to do, so we have to use right hand thumb rule or a screw rule. There is one more rule, is screw rule also. Okay, so let us, I'll tell you with right hand thumb rule. Okay, right hand thumb rule. Okay, thumb rule. Very, very simple. You will be able to understand this. So see, to get the direction, you have to have the two information. The first information is that the direction of the cross product of two vectors will be perpendicular to the plane having these two vectors. And second information is you are going to get through the use of the right hand thumb rule. Now please think, please think, please think. So now you have to do this with me. Then only you will be able to understand this concept. All of the students, see, this is my right hand. You please bring your right hand, okay, and open it, like open it wide open. Okay, let's have it wide open. Let's have it wide open like this. Okay. I'll just do one thing. Actually, I'm trying to do something. Okay, okay, that is fine. I guess this doesn't work this way. This doesn't. Okay, okay, yes, it worked. It worked. Okay, just give me a moment, beta. Just give me. So now you can see into me in a broad screen, right? Because I want to show you something. That is why I have, changed my way. Okay. Okay. Now please observe. This is my right hand. You please open your right hand and now see. And also, like if we are, all, I am assuming that we all are the normal person. So when you are having your right hand, your finger curls in one direction only, na? Okay. Anyone like it? Like, sir, my finger curls in opposite direction also. I hope all of us having the fingers curled in one direction only. That is why right hand thumb rule is used. Now we have, please see, we have this vector A and B. Now what you have to do? This is so when these two vectors. So let's suppose these two vectors are joined tail to tail. Okay. I am better how it concerns, but I'm 35 years old. Okay. Now please observe. Please observe. So this is like this. Okay, this is like this. So now you keep your thumb like this. Okay. And please observe the vector. Please observe the vector. This A and B. Now please understand this. So now you are keeping your palm like this and see your right hand thumb shall be oriented in a way, it shall be oriented in a way that your vector, your finger curls from one vector to another vector. Are you getting my point? So see what is written. Sir, we want to have A cross B. We want to have A cross B. Okay. Now what you are going to do, you are going to place your right hand thumb like this. You are going to place your right hand thumb this point like this. Okay, this point like this. And now please understand this. So your finger must curl from initial vector to the final vector. So see, you place your palm in a way. So it can be placed like this, it can be placed like this. Okay, so when we are moving from A to B, so this has to be placed like this. Now when we curl our right hand thumb like this, okay, we are moving. So this is A vector and we are moving towards the V vector. So our finger curls like this. So our right hand thumb shall be placed like this. Now when you are keeping your right hand in a way that it curls from the first vector to the second vector, in that way the direction of your thumb gives you the direction of the cross product of the vector. This is what we call as the right hand thumb rule. Okay, thumb is your direction. See, very very simple. Let's suppose a vector is here. Vector is here, so I am keeping my hand like this. Please observe. So this is my hand. I kept my hand like this. Okay. Initial A. You do with me. Because see, this thing is will be only be clear when you do it yourself. Okay. So we have see. I'll come here. I think you understood this. So we have this A vector. So I am keeping my this point. This is my origin. Okay. So this point. This is my A vector. This is my A vector. Okay, and now I am moving my fingers towards B. So it must be moving like this now. It must be moving like this now. So when it must be moving like this, so this is my thumb pointing towards up direction. So now this way, when we are writing this A and B, this A cross B, this is going to be the direction. So what is going to be the direction? So first of all, what is going to be the magnitude? So this is your C vector now because your thumb points upward. Okay, thumb point at upwards. So what is going to be, sir? It will be AB sine theta. This is the magnitude. And then it is B in the direction of C. So we can write C cap. And this is the C vector upwards. Did you get this or not? Please answer me. Hmm? Did you get this or not? Please answer me. Now similarly, now see, it will be more clear. Now let's suppose we are having a plane. See, we are having a plane. Acha, acha, she's right. No worries, beta. Okay, let's come to the point. So let's suppose we have a vector A. Acha, it's lagged. No worries, beta. Sometimes it happens. So we have A vector, we have B vector. So when we have A vector, B vector, so now I want to have, see how I'm going to do it. Now I want to have B vector cross A vector. Now please see. Now please see. So first of all, B and A vector both lies in the same plane. Now B vector and A vector being in the same plane, B vector and A vector in the same plane. So obviously, the first information is easy to process now, that the direction will be perpendicular. The direction will be perpendicular to the plane carrying A and B. So definitely the direction of this cross product will be along this, along this dash line. Yes or no? Right? Now we need to see that what is the direction. Now see, we are moving from B cross A. Okay, we are moving from B to A and we have to use our right hand. Now if I place the hand like this, so now if you see, are we moving from B to A? No, that we are not. So we have to reverse our hand. So when we will be reversing our hand like this, okay, you reverse your hand, then it seems, thank you, Azam. So, my dear, so from B to A we are moving now. So when we are moving from B to A, beta, so when we are moving from B to A, now see, my hand shall be placed like this, thumbs down, okay? Then only you will see that, see, first you place your right hand in a way that you have to place the right hand in a way that it is in the direction of the first vector, and it should be in a way that when you move it towards the another vector, your fingers must curl in the same direction. So I have to use my thumb in downward direction. So I have this B vector, I have this B vector. So this thumb is down and now B to A. Okay, so the vector moves from B to A. So here, what is going to be the direction, beta? What is going to be the direction? So the direction is going to be this direction, C vector in the direction of C. So what is going to be the magnitude? So it is BA sine theta. Now it doesn't matter if you write AB sine theta. And what is going to be the direction now? So it is in the direction of the thumb, and this thumb gives us this vector C direction. So it is going to be the C cap. Is it clear, beta? Please answer me. Okay. Okay. So see, this is very, very practical, na? Right hand thumb rule. Yeah. Awesome. Please ask me, beta. Okay, same thing we can do by the screw rule also. But I think when we can do it by the right hand thumb rule, why do we need the screw rule? Okay, when we need it, and this right hand thumb rule is going to be very useful later also. Understood? Okay. Now, so see, now see, again, let me summarize this. Yes, Adam, you can please ask me. So if we have A vector cross B vector, आजम यूट्यूब पे बेटा मैं नियरली डेली क्लास लेता हूँ. जैसे मैं लास्ट संडे नहीं ले पाया था इस पहले, क्योंकि जैसे मैं जहाँ पे रहता हूँ वहाँ थोड़ा सा इलेक्ट्रिसिटी का प्रॉब्लम हो गया था, तो मैंने कल नहीं लिया था. हाँ, मैं बताता हूँ, एक मिनट बताता हूँ. ठीक है, देखो, सबसे पहले तो ये चैनल अनअकैडमी का नया बना हुआ चैनल है. मैं फैकल्टी हूँ फिजिक्स के लिए अनअकैडमी के. मेरा नाम है डॉक्टर उमाशंकर त्रिपाठी. ठीक है, मैंने पीएचडी किया हुआ है, एमटेक किया हुआ है इंडियन इंस्टीट्यूट ऑफ टेक्नोलॉजी रुड़की से. ठीक है, 11 साल से फिजिक्स टीचिंग के कोर्स में हूँ, और मतलब जोन में हूँ. नॉर्मली ऑफलाइन में ज़्यादा पढ़ाता हूँ. ठीक है, ये मेरा बैकग्राउंड है. दूसरी चीज़, इस चैनल पे हम बेटा बायोलॉजी पढ़ रहे हैं, फिजिक्स पढ़ रहे हैं, जल्दी केमिस्ट्री का भी टीचर आने वाले हैं. ठीक है, तो बायोलॉजी आपके हर्ष सर पढ़ा रहे हैं, वो रेगुलर क्लास लेते हैं, डेली उनकी क्लास आती है, और डेली मेरी क्लासेस आती है फिजिक्स की. तो आज की डेट में क्या सिचुएशन है मैं आपको बता देता हूँ. फिजिक्स की पहली यूनिट है फिजिकल वर्ल्ड एंड मेजरमेंट्स, ठीक है, तो वो हमने इस चैनल पे कंप्लीट कर लिया, आपको उसके सेशन मिल जाएंगे। अभी हम चल रहे हैं काइनामेटिक्स में, सेकेंड यूनिट पे। इसमें हम मोशन इन अ स्ट्रेट लाइन, मोशन इन अ प्लेन दोनों साथ में पढ़ रहे हैं। तो मोशन इन अ स्ट्रेट लाइन में हम एक पॉइंट पे पहुंच गए, ग्राफ्स इन काइनामेटिक्स। उसके बाद क्या है कि मोशन इन द ग्रेविटी, रिलेटिव वेलोसिटी कॉन्सेप्ट आ जाते हैं। और फिर मैंने वेक्टर शुरू कर दिया है पैरेलल में। तो आज ये वेक्टर का, अभी जैसे क्रॉस प्रोडक्ट, ये लास्ट टॉपिक है वेक्टर में, ठीक है। तो आज का सेशन तो खैर काफी लंबा हो चुका है, तो शायद आज मैं कंप्लीट ना कर पाऊँ। तो नेक्स्ट सेशन में मैं क्या करूंगा, वेक्टर को पूरी तरीके से कंप्लीट कर दूंगा। तो हमारा मोशन इन अ प्लेन भी 80% कंप्लीट हो गया। मोशन इन अ स्ट्रेट लाइन के दो टॉपिक बचे हैं, मोशन इन द ग्रेविटी और आपका रिलेटिव वेलोसिटी इन वन डायमेंशन, ठीक है। तो मोशन इन अ प्लेन में आपको पता है कि वेक्टर जो होता है वो लगभग 80% हिस्सा तो वेक्टर का ही है। उसके बाद दो छोटे कॉन्सेप्ट बचते हैं, सर्कुलर मोशन, प्रोजेक्टाइल मोशन, और रिलेटिव मोशन इन टू डायमेंशन, रेन मैन प्रॉब्लम, अम्ब्रेला वुमन प्रॉब्लम, यही सब है ना, ठीक है। रिवर बोट प्रॉब्लम, तो उसमें जरा टाइम नहीं लगेगा। तो ये खत्म हो जाएगा, उसके बाद हम शुरू करेंगे लॉस ऑफ मोशन, न्यूटन लॉ के बारे में। तो कोशिश ये कर रहे हैं कि जितना जल्दी से जल्दी मैं आपको फिजिक्स पढ़ा सकूं उसको मैं पढ़ा दूं। फिर ये तो एक पार्ट हो गया। दूसरा पार्ट है कि डेली हम यहाँ पे क्वेश्चन सेशन करते हैं, ठीक है। अभी 7वां दिन था आज, ठीक है, अभी कल 8वां दिन होगा। तो डेली हम लोग फिजिक्स का, हाँ हाँ, मैं सारे चैप्टर ही कराऊंगा बेटा, ठीक है। मतलब अभी यही प्लान ऑफ एक्शन है, ठीक है। लेकिन देखिए, आप समझिए इस बात को कि मैं एक ऑर्गेनाइजेशन में वर्क करता हूँ। अभी ऑर्गेनाइजेशन की तरफ से मुझे जो इंस्ट्रक्शन है वो यही है जो आपने मुझसे पूछा, ठीक है। लेकिन आप ऐसा नहीं समझ लेना कि सर ने कहा था, क्योंकि देखो एक, आप समझिए, आप अभी बच्चे नहीं हैं, आप भी समझते हैं। जब कोई इंसान ऑर्गेनाइजेशन में काम करता है तो अल्टीमेट डिसीजन इज ऑफ ऑर्गेनाइजेशन। तो ऑर्गेनाइजेशन यही डिसीजन है अभी तक तो, कि भाई पूरा कोर्स आपको कराना है फिजिक्स का, तो मैं उसी की कोशिश कर रहा हूँ, ठीक है। ओके, और कुछ जानना चाहते हैं क्या इस पॉइंट पे वापस आऊँ, है ना। तो आप चाहें तो चैनल सब्सक्राइब कर सकते हैं, तो उससे क्या है ना, आपको नोटिफिकेशन वगैरह मिलते रहेंगे जो भी हो रहा है। बायोलॉजी भी आप साथ में पढ़ लीजिए, और जल्दी केमिस्ट्री भी शुरू होने वाली है, ठीक है। आई थिंक विद इन दिस वीक मोस्ट प्रोबेबली। और देखो, मेरी क्लासेस नॉर्मली 2 बजे क्वेश्चन क्लास होती है, और 3:15 से हमारा ये वाला लेक्चर वाली क्लास होती है, कंटेंट की क्लास होती है, ठीक है। हाँ आदम, कोई देखो यार, कुछ भी इसमें तो सिंपल सी, अच्छा, लेकिन हाँ एक चीज है कि यहाँ पे इंग्लिश लैंग्वेज ही यूज होती है। ये एक बात है, क्योंकि दिस इज द इंग्लिश चैनल, तो ये भी मैं आपको क्लेरिफाई कर देता हूँ। तो आपने देखा होगा कि लेक्चर के दौरान मैं टोटल जब पढ़ाता हूँ तो टोटल इंग्लिश ही बोलता हूँ। वो तो आपने हिंदी में सवाल किया तो मैं हिंदी में जवाब दे रहा हूँ, बट दिस इज अ कंप्लीट इंग्लिश चैनल, है ना। ये भी आप जानना जरूरी है आपको। आपका मतलब, अगर आप आ रहे हो चैनल पे पढ़ने के लिए, तो मतलब पूरी इंफॉर्मेशन, है ना। नो नो आदम, दिस माई ड्यूटी बेटा, है ना। So shall we continue with this topic? Yeah. So now A vector cross B vector. Oh, okay, okay, Uzma. Sorry, my dear. ओके बेटा, सो आप मतलब आ सकते हैं चैनल पे, एक बार आप सब्सक्राइब कर सकते हैं, ठीक है। उसके बाद आपको इन्फॉर्मेशन, ओके, तो नो प्रॉब्लम एट ऑल, देन यू कैन ऑलवेज कम। एंड आई थिंक बायोलॉजी सेशन हर सर इज doing a very good job, so you can continue. Okay, so let me come to the point. So see, there are two things. So let us get back to the concept. So there are two things. So A vector cross B vector. So now the vector product of, so that is why it is known as the vector product, because vector product, yes, yes. Ha. Let us come to the point, beta. Okay, so A vector cross B vector. So the vector product, the product is, the result is, I am vector again. Now, when the result is vector, so you need two things. One is magnitude, A vector. So for magnitude, A vector, B vector, sine theta. This is the magnitude. And if I say the direction, so I don't know the direction, so I'll write n cap. So n cap, how we will get the n cap? N cap will be getting from right hand thumb rule. Right hand thumb rule. Okay, right hand thumb rule. So I told you how to do it. Okay, in the Cartesian form it is going to be very very easy. We are going to see that. Now one thing also you need to be careful about, that what is this theta? So see, when two vectors, so remember two vectors are to be joined tail to tail. So theta is the smaller angle. So a smaller angle, so it is the angle between these two vectors. Theta is the angle between vector A and B. So remember that this is the smaller angle between the two vectors. It is the smaller angle. No, 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 Usman. No worries, beta. Okay. Okay. So see A vector and B vector. So A vector, B vector. So basically the angle is theta. So you have to take the smaller angle. Right hand thumb rule is clear? Yes? Okay, my dear? Okay. Now let's try one question. Uh, she said biology class is started today. I forget Harsh sir also have to take the class now. Is he taking the class today? Or because I think I'm continuing in his time. So let's do one question. We can call it a day. So let's suppose we have two vectors here, A vector, and here we have B vector. Okay, here we have the B vector. Acha, acha. So actually he's sick, a little sick he is. I have spoken to him. So might be he's not taking the class. So I am filling in na yaar. How much time it's already been? So it is 2 hours 15 minutes. Okay, I'll continue. So this is going to be 4 units. This is going to be 4 units. Okay. Okay, so we have A vector, we have B vector, we have to find A and B. So it is 4 I cap plus j cap by 2. Okay, we have 4 j cap, we have 4 k cap, and then we have 4 I cap plus j cap plus k cap root 3. Can you please answer it? Can you please answer it? Uzma. But you can also try answering it. And Bima, if you are here, you can also answer it. Please go for it. Find A cross B. Yeah, obviously. Sorry. Find cross product. Let's write here. Cross product of A and B. So now how we can do it? So very simple, sir. First of all, see. So we need a magnitude. So what is going to be the magnitude? So A cross B. What is going to be the magnitude of A cross B? So magnitude of A cross B, it is going to be AB sine theta. So that is A, then B and sine theta, that is sine 30. So this is going to be 4. This is going to be 4. Okay. Now what is going to be the direction of it? So the direction is given by 4 n cap. N is the unit vector in the direction of it. Now see, this is very, very easy. From options also you can see. So now we understand that AB is in XY plane, right? Clearly from this question we can see AB is in XY plane. So what is axis that is perpendicular to XY plane? So that is the Z axis. So obviously the cross product is happened to be in the Z axis, isn't it? Yeah, Uma, please do that. Okay. So tomorrow we may not be okay. You please subscribe the channel. Actually, tomorrow what happens now? Tomorrow we may have the question session. We may not have the conceptual session tomorrow. It may be a possibility. Are you getting my point? Because today we are going to, if we are going to complete this cross product, I want to give you a day to revise. Okay. So you please subscribe the channel. If not tomorrow, day after tomorrow, we'll be having. So I'll be coming up with this motion and the gravity, and I wanted to do it in one go. Okay. So meanwhile, what you can do, beta, you can, if you are coming in the next session, you please revise motion in a straight line. So you will see 1, 2, 3, 4, 5 parts like this. Yeah, yeah, yeah. Okay, vector is going to complete it today. Okay, so please come prepared for the next topic. That will be motion under the gravity. Are you getting my point? So I suggest you leave the vector time being if you are continuing from this time. So see, there are motion in the straight line 1, 2, 3, 4, 5. So you see some sessions there. Okay, okay, graphs and kinematics and all this. So that will be more helpful for you to understand the upcoming session. And if at all you are not able to see, please do come in the session. Definitely we'll take care of it. Don't worry about it. If it's small information is required to give in, I'll give you that. If that information is very big, I'll suggest that go watch this video and then also you can do that. Okay, but for that you have to come to the session. Okay, like the other students, they are normally coming to the session daily, so they are having the pace now, right? Okay. Okay. Now please understand this. So first of all, what I was saying, so I was saying that this A and B vector, these are in XY plane. So obviously the Z vector, okay, it is the vector is going to be in the direction perpendicular to the XY plane. So perpendicular to the XY plane, that is going to be your Z direction. So basically the vector is going to be in the Z direction. So obviously it is going to be K cap. But if at all it is written plus 4 k cap and minus k cap, what you would have done? Now for that you require the direction. Now please see right hand, using the right hand. So see, your tip of the right hand has to be where the vectors joining each other. Now please think, this is xy. So definitely your thumb will be either pointing towards you or either pointing away from you. If it is pointing towards you, that is positive Z. If it's pointing away from you, this is negative Z. Now see, we want A cross B. We want, see, please understand this, we want A cross B. So when we want A cross B, beta, when we want A cross B, so we need to curl our fingers from A to B. And if we are placing our right hand in a way that we need to curl the vector, we need to curl from A to B, so we need to place the vector like this. Okay. Okay, so when you are placing it like this, yes, Shishai, when you are placing it like this, then only this go from A to B. Now, so your finger, your thumb must be pointing towards you. When the thumb is pointing towards you, that is the plus Z direction. That is, we have written plus 4K. Now, if at all they have asked us that what is vector B cross vector A. Now, in that case, your thumb would have gone like this, reverse of it, like this. Are you getting my point? Like this. Okay. Okay, so when this happens, so that means that you are curling your finger from B to A and this thumb point towards the screen or towards your copy or away from you. So that means that is minus of K. Okay, so what is going to be the answer? It is going to be 4K cap. I hope it is fine to everyone, isn't it? Now let's see one more very important thing. Now please understand this. Actually, you get one thing from here, that cross product, one observation, cross product is not commutative, isn't it? It is not commutative. or it doesn't follow the commutative law? What first question, beta? Sir, you are asking the A cross B. He said, what first question? Sir, can you ask, sir, can you answer my first question? Where is the first question? Where is the first question, beta? I couldn't see it in the chat. Can you tell me where is the first question? Hmm? IIT one. Which one? I just can you ask the question again? But I cannot see it in the chat. No, sir, the IIT one. Which one? I didn't get the question. Can you please ask me again? Can you ask me again, beta? Uzma, these are on this channel only. Go to the live tab. If you are searching in the videos, you wouldn't get them. You go to the live. So when you see the channel, na beta, you need to go to the live tab. You are going to see all the lectures there. Okay, all the academic lectures are in the live section. So you say, what is your question, beta? See, it is not like that actually. Some criteria are there. Okay, you found it, na, Uzma? Okay, but you not 75%. You have to see there's no like criteria. There is, I think, are normal because see, normally what happens, I didn't, like normally what happens that those who are able to crack this JEE examination, they get more than 60-70% very easily in the boards. This is the general trend. So normally this question no student asks me ever. Are you getting my point? Okay, Uzma. Wonderful. Okay. So there is no such criteria as far as I know. Okay. Okay. So shall we proceed? So let's do it in another way. Now let's see some special cases first. In the same pattern we moved in the dot product now. So special cases. So in the special cases, see if theta is equal to 0 degree, if theta is equal to 0 degree. Now when the theta is 0 degree, so if two vectors are parallel to each other, please listen to me very carefully here. This is very important. So if two vectors are parallel to each other, the angle between them is going to be 0 degree. The angle between them is going to be 0 degree. So if angle between two vectors is 0 degree or they are parallel vectors, what is going to be their cross product? It is going to be 0, isn't it? No, Ozma, I do not have. If you want to like do follow me, so you can join Unacademy app, not the paid one I'm asking. If you want to do that, you can come you see in the Unacademy, so there will be you will be able to find me, Umashankar, but you can follow me there. Okay, Telegram I don't use. Okay, and personal telegrams are also not allowed. Okay, so on Unacademy I'm taking special classes also, so that is free of cost. Okay, so you can come there, you can search me, follow me, you can join the community and all that, but you can still be here, so it's your choice. It's your choice completely. Okay, I'm not pitching anything, right? Okay, don't take it otherwise. All right. let's come to the point. So if two vectors are parallel to each other, if two vectors are parallel to each other, beta, if two vectors are parallel to each other, the cross product of theirs will be 0, right? Isn't it? But the 0 is also a vector, remember. Okay. I told you na, that 0 is also a vector. Don't forget it. So cross product of two vectors is a vector. So the 0 is also a vector. Shita, I think some of your, messages are lagging or something. Okay, let me complete this first, then we'll talk about it. Okay. Otherwise, things will be confused. So two vectors parallel to each other, their product is going to be 0, right? Now, second thing, if two vectors are anti-parallel to each other, okay, so this is also going to be 0, isn't it? So negative of 0, negative of 0, it means nothing. It is going to be a 0 vector. So what is the 0 vector? So 0 vector is having the, so I told you, I defined the 0 vector, null vector. 0 vector is something which whose magnitude is 0, but it has arbitrary direction because any vector has some direction. Clear? Now please observe this. So we are having theta is equal to 90 degree. Now if theta is equal to 90 degree, that means if two vectors are orthogonal, see, very, very important. So two vectors are orthogonal, what is going to be their, what is going to be their cross product? It is going to be 1, okay? It is going to be equal to AB, right? But it is only giving you the magnitude of it, not the direction. Okay, so we are talking about the magnitude. Direction we already know, na? Right hand thumb rule, we can take the direction. Okay, okay, clear? Okay, so these are the three things, right? Now, what are the properties of it? What are the properties of cross product? What are the properties of the cross product? So what are the properties of the cross product, beta? So first property was it is not commutative. We just have seen this. It is not commutative. Okay, it is not commutative. So we just have come to know now. See, A cross B. See, very important information. So if I say A cross B theta, so can we write A vector cross B vector is equal to B vector cross A vector? This is what we mean by commutative now. B vector cross A vector. Okay. So this is not the happening now. This is wrong. Okay. This is wrong. Why, sir? Because if this direction is n cap, this direction is going to be minus of n cap. Do you agree to it or not? Yeah. We just have seen that. Like if A cross B is this, then B cross A is this. So see, what we can write? We can write that this is not the right thing because vectors having two vectors, yeah, two vector will be same. Okay, two vector will be equal only when their magnitude and direction both are same. But here the magnitude is same, but direction is not the same. Okay, magnitude of both of it is same, na? So can we write like this? Can we see? Can we write like this that A vector cross B vector is equal to minus of B vector cross A vector because their magnitude is going to be the same but the direction is going to be opposite. So this is right thing to write. Okay, this is going to be very, very useful, isn't it? Please answer me. Okay, okay, please answer me. Very, very easy, no problem at all. I think we got the feeling for it. Now, second thing is vector product or cross product. Both are the same thing. Sometimes it is also known as, vector product because the result is vector. So cross product obeys distributive law. Cross product obeys distributive law. So what is this distributive law? So cross product obeys the distributive law. That means if we write A vector cross B vector, so distributive law, both of it, like dot product also obeys, cross product also obeys. So A vector cross B plus C vector, so it is going to be A vector cross B vector plus A vector cross C vector. Understood, beta? Understood? Okay. Likewise, the dot vector. Okay. Okay. So very, very simple. And the third property is, see, so in dot product, so dot product of a vector with itself, dot product of a vector with itself was 1. I dot I becomes 1, right? But cross product of vector with itself, cross product of vector with itself is 0. Okay, because see, if you are writing a vector, if you are writing a vector cross a vector, okay, so what is the angle it makes with itself? So sir, obviously it makes an angle of 0 degree with itself, right? Obviously it makes an angle of 0 degree with itself. So when it makes the angle of 0 degree with itself, sine 0 is 0. So when you are writing the cross product of a vector with itself, okay, it will become 0. Okay, so from this point onwards, beta, I'll be continuing in the next session. So not much of vectors left, but we have to see some questions also, we have to see some things also. So in the next session, we'll be concluding this cross product. Okay, okay, so I'll have to tell you something, because now I think the session has gone for almost 2 hours 30 minutes. Okay, right? So I'll keep it to this point and we'll shall continue. So in the next session, okay. So in the next session, definitely we'll be completing the vector. Understood? In the next session, we'll be completing the vector thing. Okay. And afterwards, we are going to give a pace and we'll see the motion and the gravity, the relative velocity. We are going to see this projectile motion and the circular motion. Okay. So that will be all for today. Please guys, don't forget to subscribe the channel, and so that each of the information will be with you. So with this, thank you very much. Have a good day and we'll see you in the next session. Keep studying.